All right, so solving logarithmic equations, we're going to look at a couple of ways to do these. Some of them are, I think, pretty easy, and some of them are a little bit more difficult. But let's take a look at this one. So we have log base 2 of x plus log base 2 of x plus 2 is equal to 3. So this is what we have to remember here. Now what we want is we want to put these things together as much as possible. So I'm looking at rule number 1, which says that log base a of a number plus log base a of another number, this plus sign, means that we multiply them. So I'm going to take my log base 2, and this rule says if there's a plus sign in between here that we're allowed to multiply. So this x is this one, and this x plus 2 is this x plus 2 here, right, is equal to 3. All right? So from here, I'm going to go ahead and distribute in to here and obviously to here and get log base 2 of x squared plus 2x, right, is equal to 3. Now, keeping in mind what logarithmic functions mean, this is the base. It's log base 2, so we can take this and raise it to this exponent and set it equal to this, which is just fundamental to properties of logarithms. So this 2 and this 3 is this 2 to the third power, and we already have this x squared plus 2x, right? And there's nothing holding that together, so, and 2 to the third power is 8. Now we have to keep in mind, and this is kind of where stuff falls apart for some people, is that they don't know what to do from here. Well, this whole thing is a quadratic, right? So we have to think in that pattern. So if we see this pattern, then we have to start thinking back to algebra that a x squared plus bx plus c is equal to 0. So we're going to move everything over this way, aren't we? We're going to have x squared plus 2x minus 8 is equal to 0. I'm going to just keep moving, just do our algebra here. We're going to factor this out. So we're going to go ahead and factor. When we factor this, we get x plus 4 times x minus 2 is equal to 0. Solve this for x is equal to negative 4, or x is equal to 2. And then we have to go back and check a little bit. So here are our two answers. We have to go back and see if that's going to work out well. And we look back up here, and if we put negative 4 in here, that's not okay, right? We know this value right here has to be greater than 0. So our only answer is x is equal to 2. All right, you know what, you guys, let's do one more, okay? Let's do one more really quick. So let's do, oh, you know what, let's do this one. So log base 5 of 2x plus 3 is equal to log base 5 of 11 plus log base 5 of 3. So we look at our second rule of logarithms, and we know, oh no, same rule that we used on the last one. That's terrific, right? So we have this plus sign, which means that we can add these two values. I'm sorry, we can multiply these two values. So we get log base 5 of 33 is equal to log base 5 of 2x plus 3. From here, we're going to go ahead and drop these logs, and as long as your professor is cool with it, but if he or she asks why you're doing this, then what I would say to you is simply this. The reason that this is okay to do is because logs are one-to-one functions. That is to say that if this is log base 5 of this and this is log base 5 of that, that this value and this value have got to be the same. There's another way to prove this, and the other way to prove this is to take this base right here and raise it to this, and it would automatically cancel this out, but I'm not going to bother with that. So we have 2x plus 3 is equal to 33, and you know if we solve, we're going to get x is equal to 15. And if we plug it back in, we'd get 2 times 15 is 30, plus 3 is 33, and we know, because of the rules of exponents, that that's true, don't we? Okay, you guys. Super. Super.